Okay, well, we better get started because I know Jackie, which means he has a lot of slides. Welcome. You're here. We're here for Jackie's PhD defense. He's worked with, we'll say, N years with Monica and myself. You know, what you're going to see today is just a small sampling of the many different projects Jackie's done during his PhD, which should be a lesson to PhD students to know. You don't have to put everything you've done in the dissertation, because if Jackie did that, there'd be like 15 chapters at this point, which even less people will read. So anyways, you're going to hear about his PhD dissertation work, and then we'll take questions at the end of that. So during the talk, maybe just clarifications if you need it. And then we'll have a closed door session after that with the committee where we'll decide his fate.
All right. Okay. Thanks, everyone. Hi, everyone. I'm Jack Young, a PhD candidate in the computer science department. And today I would like to introduce my dissertation work on multimodal AI-augmented user interface development architecture, or I call it MAUI. Today we have great graphical user interface apps. Here is an example PowerPoint. I can use it to change text boxes, pictures, shapes. I can adjust fonts, colors, line styles of those objects to a very precise degree on the graphical user interface, or GUI for short. However, when for some actions it becomes inefficient and repetitive. For example, for batch actions, if I want to apply the same action to multiple objects, I want to change all of my animations to 0.3 seconds rather than the default 1 second. I have to do it manually for all of my objects on all of the slides. Similarly, for less common features, for example, I want to adjust the underline style. I have to go through menu after menu after menu. In fact, actually 7 clicks to get to this menu where I can change the settings properly. So how do we solve this problem? Let's see a demo of the project that I do.
Make all words Rex Genie red and bold. Let's go. Much better.
So the way we make it work is the user only have to state a high-level goals, like making all the word red and bold, and then the system will automatically execute low-level actions. Rather than the user have to do them, like select a part of the text, change color, make bold, select text, change color, make bold 3 times. So this kind of idea of where you can interact with the interface with gesture and voice is called multimodal interactions. And then we are specifically focusing on a type of multimodal interaction where we allow users to express their high-level goals rather than the low-level actions. So to implement that, let's look at how GUI works today. Today's GUI work with touch and graphics interactions. The user would be able to see the graphics rendered by the GUI framework, and they can touch on the GUI generated. And then that would translate into actions to the app's logic code. So the user usually have a goal in their mind. They have to translate them into repetitive interactions, and those get translated from the GUI framework to be many individual actions that actually got executed. And then what we are trying to do today is we want to use today's GUI framework architecture combined with today's state-of-the-art AI, like those used in ChatGPT, to achieve multimodal interaction with the framework so that we can help developers easily build multimodal interactions. To achieve this good multimodal interaction future, we would like our system to be super expressive, meaning that we can support those rich multimodal, compositional multimodal interaction I mentioned before. That means the user specify high-level goals and the system execute those low-level actions. And we also want it to be super easy to build so that developer can easily expose those APIs from their app to support those multimodal interactions. We also want it to be consistent, meaning that when the user sees a similar GUI, they should be able to expect that a similar set of actions are available rather than they just don't know what's supported. Today, there are a lot of companies are trying to build towards this target of multimodal apps. Here we have Notion, a notebook app that support AI features to allow people to ask questions. Microsoft 365, the productivity suite, have all of those chatbot enabled, which allows document generation, question answering, and basic editing. And then even Windows these days came up with a Copilot feature where we can chat with different features of the operating system. These existing work are usually made with the LM plus a patch method, meaning that outside of the typical GUI workflow, which look like this, they allow users to interact with natural language with the AI model. And the AI model will be able to generate some function calls through this function calling interface. And what they're doing is basically generating these kind of function calls where you have a function name and certain kind of parameters. So the problem about these existing apps is that they don't really solve the three targets I said in the beginning. For example, for expressiveness, a lot of them, actually all of them cannot handle rich multimodal interaction with the compound action, the type that I mentioned in the beginning. They're also not very easy to build. They require developers to provide different programming interfaces for voice and GUI interaction, and that takes a lot of time. And finally, because their apps are built in an ad hoc way, there's no standard way of doing this. The same GUI might support different sort of actions. So to tackle those problems, we introduced MAUI architecture, which is our solution to all of the problems listed above. It has a unified interface for the user, and then the framework would handle the AI rather than the developers. And we have a composable abstractions to support the rich multimodal commands that we talked about before. So I'll demonstrate how we came up with this by examples. So this is Word, and I try to ask Word to help me sort this table based on rating from smallest to largest. I tried this exact command in Excel, it worked, but then in Word, it just prints me all the ratings rather than actually sort it in the table. This is because with the function calling interface, the touch and graphics and the natural language is implemented in an ad hoc way. Similar GUI interface have vastly different multimodal support. The same query works in Excel, might not work in Word. To make this a little bit better, we change this interface in the MAUI framework so that the framework has, like how GUI handles it, the framework handles all the interaction, all the multimodal interaction from the user. And this way, there will be a consistent expectation across similar GUIs because similar implementation gives a similar code to MAUI framework and would support a similar multimodal interactions. Second problem we noticed is that I tried this command. I'm trying to plan the outline of my talk, and then I ask bold all the lines, including word multimodal interactions. And then I get this feedback that formatting actions are just not supported, while on the GUI, you can easily change formatting in Notion. So I think that is caused by the function calling interface. Right now, the developers would have to implement a separate interface for the GUI interactions and for the voice interactions. And this is basically two interfaces for the developers to do. And obviously, developers are going to prioritize GUI framework, which is what they are already building. All of the features are there. And then it's going to treat those voice interaction as a second citizen. So instead, in the MAUI framework, we make the framework directly interact with the AI models to send in the user's ambiguous input and then output more concrete output so that we can actually execute on that. And in this way, the developer has to do less work and then would be able to make more features available across the board. Finally, I tried this in Excel. I said, make all the clothing category red. So you can see the category has multiple different categories, and we only want to make the clothing cells red. But then it didn't work because it doesn't support formatting to a subset of the cells, although it can highlight this entire column. So we think that is because right now we have this action interface, which works well for GUI, right? If you click a button, it executes the action. But then for rich multiple interactions, this framework is simply not good enough. So in MAUI, we replaced it with a composable abstractions. And then that would support rich multiple interactions. For example, the same command in the Excel example can be translated into a function like into a statement like this, which involves multiple function calls. So to sum up, today I would like to introduce MAUI architecture, which is a modular composable abstraction. And it would better separate multimodal input and output from the computational model. And it enables developers to create adaptive, intuitive, efficient, and capable multimodal interfaces in less time with less training when using traditional development frameworks. So before I dig deep into the projects, I want to first introduce the two types of multimodal interactions that MAUI is trying to target. First, there are explicit interactions, the kind of rich multimodal interaction I mentioned before, where the user is giving very explicit commands for the system to be able to fulfill. Another type of multimodal interaction is more implicit, meaning that the user's behavior or feedback, the system is going to observe that and optimize for the user's use case. So now on the explicit interaction side, we have PowerPoint, as we demonstrated before. There's Yelp, where if you're asking for a restaurant for a specific criteria, that's kind of explicit multimodal interactions. There's also a food ordering app where you know you want to order something, you're just giving some criteria. Later, I will introduce my project React Genie and Genie Wizard that's trying to tackle explicit interactions. For implicit interactions, such as when you are using a map application and the map is giving you guidance, so the map is taking the active role and is observing your behavior and change the guidance, so that's kind of more implicit. And there's also the case for cooking a guidance app and then furniture assembly apps. Those apps are observing the user's behavior and then changing their actions accordingly. So I will introduce my framework called AMA, trying to solve the implicit interaction problem. Later, I will have a lot of this figure, which is the MAUI framework, and I will instantiate those modules which are kind of abstract at the MAUI level. But then I'll say, oh, for example, a certain framework will use these as composable abstraction, these as concrete output, and these as ambiguous input later in the talk. So the contribution of this work is basically we propose modular abstraction for explicit interactions. And then the benefit for those explicit interactions we demonstrated contains intuitive, efficient, and capable apps. And then it would allow developers to spend less time and less training. For the implicit interactions, we have another abstraction called activity specifications. And then we have demonstrating user studies showing that it is adaptive and efficient. So without further ado, I'll dig into the first framework, React Genie, which is for explicit multimodal interactions. And this work is accepted at CHI 2024. So the target interaction for React Genie is all sorts of different things involving content and actions in an app. Specifically, we're very, very interested in off-screen content. For example, I see this in my Home Assistant app. I see some activity in my living room sensor. And I would like to be able to just say, show me the log in the same room. And then I would expect the framework to be able to index the room that the log is located in, and then find the sensor is located in, and then find the log in the same room, and then finally show me the history status of that log. Similarly, we have a lot of apps these days that has like limited buttons on their screen, right? Maybe if I want to share this video, that's fine. But then I also want to share this account, there isn't a button for that. Or maybe I want to share this comment, which also there isn't a button for that. Although like if you click 5 or more times, you will be able to do this. So the feature is there in the app. So there are so many things that there is limited screen real estate. We want to be able to access them with multimodal interactions. And finally, we can combine different actions and content together. For example, this is Uber Eats app. It supports listing my ordering history. It also supports placing an order. And I would like to be able to just say, order what I have ordered last time, and then I would expect the app to be able to place that order for me. So the way we solve this is by using the MAUI architecture, as I described before. And specifically for this framework, React Genie, we used the abstraction called object-oriented state abstraction, which I will describe in details later. And then we use AI, we use LLM specifically to use, we send LLM prompt to LLM, and then we ask LLM to generate a language called NLPL, which is a natural language programming language that we define. And this is how we can understand the user's command and then execute them. And this is for solving explicit rich multimodal interactions. So to translate those multimodal interactions to NLPL, the way we make it work is the user has some command. This is the part that's a little bit ambiguous about. And we read the developer's state code. State code is the same as logic code. That's where all the features of the app is located. By having what is available and what the users want, we have this React Genie library gather both of them, generate an LLM prompt, and then we ask large language models to generate NLPL, which is the language I'll describe later, that can basically describe users' action, describe users' intent in concrete actions. And this is an LLM-based neural semantic parser we built for React Genie. We built this framework so that we want the app to be expressive, easy to build, and responsive. What I mean by expressive is that it would support a rich multimodal voice plus touch interactions, involves many actions as I described above. It would be easy to build so that developers who are already familiar with GUI framework can easily get started and build in React Genie. Finally, we also wanted to be responsive, meaning that respond to user interaction with clear feedback and predictable behavior. Due to the limited time today, I'm going to mostly focus on the first two for this, but the full thing should be available in the dissertation document. So first thing we need to consider is there are so many different features. Let's say in PowerPoint, hundreds more features. How do we combine them in an arbitrary way as the user specifies? So if the user want to say, make this text box bold in the slide master, recall the typical way to do this is use function calling. So the developer will implement a function for that. And if the user says, make the border of this shape with little dots, it will implement another function. And then make everything right aligned on this slide, another function. Make everything, every shape on this slide above this yellow, we need another function. So as you can see, with a traditional function calling interface, almost every single user command has to be translated into a new function. There could be a million ways people can do stuff. That means developer has to implement a million functions, test them, and make them work, which is basically not really possible. So the React Genie way of solving this is by translating these user commands, breaking down into smaller segments. Like if I want to make this text box bold in the slide master, I would get the current slide, get a slide master, find the object with the same ID, find the text range, and change the font to be bold. Similarly, we can translate all of those commands in a similar style, where we're breaking down the large monolithic command into smaller composable segments. So this language, as I described, is NLPL, and then this can solve the compositionality with compound chain function calls. Another side of it is how do we provide those functions so that we can execute those NLPL? PowerPoint has like more than 10 APIs. It takes a long time to encapsulate for multimodal use. These days, the typical way to do this is IntentKit from Apple, Actions on Google. Those are voice frameworks that allows developer to expose certain functions to voice. But then those frameworks, basically, you have to declare one set of function for GUI and a separate set of function for voice, which is 2 times the work. And then we basically take a look at what are the existing code look like. So these are the existing apps logic code. They roughly look like this, where you can see there are some actions here, and those actions are kind of what we need. For example, for a food ordering app, there are fetch order, create a new order, and add some food to order. But there's no way, there isn't the explicit saying, oh, this function takes in these parameters as types, and then output this value and what type it is. So it's hard for us to chain them together to execute what the users want. So instead, in React Genie, we propose a new way to implement the state. And that involves first creating some classes which are representing a part of the state, the entire app's state. And then there's also properties within the class, and there are functions within the class. This is similar to object-oriented programming. And then there are also explicit type annotations for all the parameters and all the return values. So that's what we call this abstraction object-oriented state code. So by doing it this way, we can see that those actions and those parameters are basically what NLPL needs. NLPL is basically you executing some of those functions and retrieving some of those properties to execute what the users want. So to make it super easy for developers, we simply ask them to add some annotations. And by reading those annotations automatically, React Genie's library will be able to figure out what are the features in the app so that we can generate proper NLPL using large language models. From the developer side, using React Genie is super simple. So right now, developers are writing their state code, which implements the features in the app. The UI code, which you can see is basically a function that's generating some HTML code to describe what the UI should look like. With React Genie, the developer implementing in this way, where they added some annotations in the state code to tell the framework what functions and properties should be available. On the component side, they write annotations that look like this to have explicit mapping between which object on the screen mapped to which object in the memory. So basically, it looks like this. Developers implement those object-oriented states, and then they implement UI components, and we render a UI that looks like that. And then we know exactly where each pixel is mapped to which memory object. So let's see it in action. Reorder my last meal from this restaurant. Reaction first uses its neural semantic parser to translate the user's command to Reaction's domain-specific language NLPL. However, here we don't yet know what is the current restaurant the user is referring to. Therefore, Reaction first reads the tag point from the UI and uses developer's UI component code to map the tag point back to a state object. Now Reaction can execute the DSL. It first resolve the last order from the restaurant, and then it creates a new order and place all the food item in there. Finally, it reuses developer's UI component code again to map the result to a graphical UI and text feedback. So that's how Reaction reuses developers' code to support multimodal interactions. To tell how good Reaction is as a framework, we want to know from the developer side whether this is expressive enough for various different multimodal apps. We also want to know whether they can save developers' development time, and then it is easy to use and easy to learn for novice developers. So we first build 3 demo apps. We have a food ordering app, we have a social media app, we have a document signature app. We can send documents to other people for signatures. And then while implementing them, we found out only 5% of the code, which are those annotation examples, must be written to handle multimodal interactions, which is a very small amount of work to support a very rich interaction interface. We then started to build a demo app that is like slightly smaller than the 3 examples I shown before, which is a timer app where user can start and pause timer with voice. They can start and stop timer and filter timers by a certain category or remaining time. And we first asked an expert developer to build an app with React.Genie compared to GPT function calling, which is what we're comparing with. We found out that developers spend less time building with React.Genie. They write less code building with React.Genie, and they explore more features when building with React.Genie, especially because of the rich multimodal interactions. We then asked a novice developer who none of them have ever built any multimodal app before to try React.Genie. We asked them to first learn a tutorial and then construct this timer app based on a GUI boilerplate where we give them a working GUI app but with none of the multimodal features. We find that after the study, they have very high comprehension of how this multimodal framework works. In fact, they answered 99% of the questions correct. And it has a very fast completion time. They completed this multimodal app in only 67 minutes in our lab. And then we find positive feedback on ease of use. And many participants are actively asking us how can they use React.Genie in their real-life applications. In fact, React.Genie is available in NPM store, so everybody can try it out. So we also want to know how good is React.Genie as a framework. So we tested partial performance, and we want to know whether the multimodal UI generated is actually usable and efficient for users. On the partial side, we did an elicitation study. We showed an app and asked people to use multimodal interactions as crowd workers to use this app with multimodal interactions. We gathered 172 rich multimodal commands, and out of them, there are 101 commands that are supported, meaning our state code actually have the functionality that they asked for. And then out of those commands, React can correctly parse 91% of them. There are also some commands where they ask for stuff that our state code doesn't currently support, and they can still generate sensible NLP. I'll talk about this definition of sensible later for 53% of them. And then we also have this food ordering app that we actually ask people to use it. And then we compare the user performance and experience with this multimodal version of the UI and another version which has GUI only. For the 60 participants, we found that React.Genie saves 40% of people's time, have lower cognitive load and higher usability. 11 out of 16 participants preferred the multimodal version. The reason for people to prefer otherwise is because they have bad experiences with automatic speech recognition before. So using the MAUI architecture, React Genie has this modular abstraction, what we call object-oriented state abstraction, and we demonstrated for developers it is too easy to learn and have less time usage. For users, they are intuitive and efficient. So we didn't just stop there. We have the framework. We try to build an IDE to help developer better develop in React Genie. And the thing we want to solve with the IDE is this problem that we mentioned before. It works great for the commands that are supported. 91% of them are parsed correctly. And remember, those commands are all rich multimodal commands, meaning that they involve multiple actions in the command. However, but for unsupported command, it becomes a little bit interesting. So there are 41% of the command we enlisted are actually not directly supported by our implementation of the state code. And this is because when users are allowed to speak whatever they want to speak, they start to mention features that are not existing on the GUI directly. But the good news is that it can generate our parser can generate sensible NLPL for 53% of the time, even for those unsupported commands. What I mean by sensible is that it would use a non-existent function in a reasonable way. So we all know LLMs these days would hallucinate, right? So I'll tell LLM that these are the available features, but when the user asks for something that doesn't exist, the LLM would still generate a working NLPL, but it would mention a function or properties that does not currently exist in the state code. So we actually can leverage this feature to help developers. And the format we're helping developers are in IDE, and we are heavily inspired by how GUI IDEs work. So GUI IDEs help developer in the same time frame follow the UI best practices and visualize their design change, so they know how much they have done and how much they need to do to accomplish what they want. Similarly, MAUI IDE want to do the similar thing, where in the same time frame we would help developers to refine their app logic code, and so that they can support more common actions, and then they can visualize their progress while they're implementing it. This is the IDE we built. On the left side, as you can see, developer can write their early state code. What I mean by early stage is they do not even have to implement their function. As long as the structure are there, is fine. And then on the right side is where Genie Wizard gives us guidance. Specifically, the most important part is the suggested feature. We will basically list unique features in the format of, oh, this function is missing, or this property is missing, or this class is missing, so that developer can implement them. They can even expand on the unique features to see what are the commands that are mapped to this unique feature. And if they hover on them, it would show the generative user utterance. For example, customize my margarita pizza, add extra cheese and olive, stuff like that. And then developer can write their new code over here. And then we will be able to tell the developers their progress on how much they have implemented based on the features listed here. So in this case, the developer has already improved the coverage by 20%. Genie Wizard works by simulating user testing portion. For GUI, the user testing is pretty mature. Designers would build UI prototypes, test it with users, figure out what features are missing, and then write a design specification document to list what features the developers need to implement. For multimodal interaction, it becomes a little bit more complex because there's not an easy way to build multimodal prototypes. You probably would have to Visual it, and then that takes a lot of designer time. And even if you know what functions are missing, designer does not necessarily know which function to implement to support that feature. So instead, we start with developers' code skeleton. So they only have to write the state code of all the functions they are planning to write rather than writing the implementation. And we will generate potential user utterance from that. We use our slightly improved zero-shot parser so to translate those commands into those operands into commands and then figure out what features are missing. So basically, a quick summary is we start with code signatures, we generate interactive dialogue, we then, from the interactive dialogue, we generate parsed DSLs, and then finally, we get features from the parsed DSLs. To test this, we asked 12 developers to do a within subject study. We asked them to improve 2 apps One is a food menu app, and the other one is a hotel booking app. We asked them to use two different tools, a Genie Wizard, which is the tool I just demonstrated, and VS Code, which is what Genie Wizard is based on. In the result, we find that with Genie Wizard, developers can identify 42% instead of the 10% of the missing functions within the same 1 hour time frame. So using the MAUI architecture, Genie Wizard is the same abstraction as React Genie. For developers, it's easy to learn, and for users, they can enjoy more capable apps right out of the box. So that's the frameworks I built for explicit interactions. And here I will talk about AMA, which is a framework I built for implicit multimodal interactions. And this paper has been presented at IEEE 2024. So we also use the same MAUI framework for AMA. And in AMA, we are trying to use this modular abstraction of how the developer describing roughly how the task works. So we call this activity specification. And we use this user model as the AI model, and we send user feedback to the model to slowly refine, to refine the user model to make it closely emulate what the user would do, so we can get an estimated utility for AMA to be able to adapt interface for users' implicit behavior. There are so many different places where we might be able to use those implicit interactions. And specifically, we're very interested in, like, for example, map guidance applications, assembly guidance interfaces, and cooking guidance interfaces. All of those interfaces needs to closely observe whether the user is responding well to their commands, and then figuring out what are the best modality, what are the best guidance to give to the users. So we would mostly talk about guidance apps. How do we help users with guidance apps for implicit multimodal interactions? So guidance apps are pretty popular these days, and then we have very good computer perception that's getting better every day. But right now, a lot of these guidance apps are not really adaptive to the users. So what I mean by adaptive is threefold. They're adaptive to progress. For example, in a map application, we would want the app to be able to respond to my current GPS location, knowing if I make the wrong turn or the right turn, and give me the instructions accordingly. Maps app kind of have that, but like the guidance app for like cooking or for furniture assembly, that does not currently have that. And for preferences, this is not a guidance app, but then this is a good example. Spotlight search would be able to learn my daily behavior, what apps I open, what actions I'm going to execute, to figure out what is my preferred action predicted based on my past actions. Adaptive capability is a little bit more complex. We want the app to be able to know the user's capability and then change its behavior based on that. There are a little bit of work right now on that for guidance app. For example, this app is trying to change the guidance level of detail, that's LOD, based on whether my previous instructions has timed out, meaning that I didn't follow it in time. There are also another work that changes the level of detail based on the user's stress level. And basically, we're trying to change app's behavior based on the inferred user's capability. And the last part is particularly hard because previously, the work are just depending on the developer's experience and research. Does not necessarily generalize. For example, these two work, one are trying to adjust the level of detail based on whether the user timed out, and then the other one is trying to adjust the level of detail based on stress level. And the common theme for these work is that they, based on some observation, they make some sort of adjustments. And that mapping is kind of hard-coded. But what we really care about is not necessarily adjustments. We actually care about different targets. For example, for cooking, we care about the time to finish that meal, and we care about whether they follow the instructions closely so that the taste is good. And for writing and drawing, maybe what we care about is the quality of work. So we call that target. And AMA solution is basically doing user modeling, basically modeling this process of under the same observation, what kind of adjustment would lead to what kind of target. So that we will build a user model that does that. So from the observation potential adjustment, we would get an estimated target. And what AMA is running is basically AMA is trying to find the best adjustment that will reach the best target. For example, for one user, maybe one target is the best. So we would choose the adjustment corresponding to that target. Similarly, for another user, maybe another target is the best, so we would choose adjustment accordingly. So that's the core idea of AMA, and let's see how AMA works. We design AMA as an easy-to-adopt development framework for creating adaptive guidance applications. Developer starts by providing this activity specifications that provides actions, which is the low-level trackable actions in the activity, and they also provide steps, which is higher-level steps that group related action together. And this is the level we're giving guidance. So we would tell people to fry something, but we wouldn't tell them to grab a pen, put the object in there, and then turn a switch. That would be too low level. And we also have the overall task, which are decomposed into different steps. And this is the level of guidance the user is choosing on. So user says, I want to cook fish and chips, for example. And we ask developers to implement different multimodal UIs, which are options for presenting each step's navigation, each step's guidance. And we ask them to provide a user model template, which is a starting model of how user attributes like reaction time, walking speed, and action time may impact user performance metrics. From this activity specification, AMA automatically generates a state tracker and a guidance planner. So as the user are performing those actions, the state tracker would automatically update the status of relevant objects and actions that can be manipulated. And this determines the possible next steps for the users. The guidance planner then uses the user's current user model to simulate estimated outcomes of each potential next step. And then it selects the optimal policy, which is the sequence of steps that lead to the best predicted performance. The chosen next step is then presented to the user through the specified multimodal UI. And the user's resulting performance, which is whether it's success or failed or the completion time, is observed as feedback. And this is used to dynamically update the user model to better predict the individual's capability and preferences. And the goal is that the more the user interacts with the system, the better it can tailor itself to the user's specific needs. We demonstrated AMA in a cooking assistant application. We start with a commercially available cooking simulator app, and then we build a plugin to hook all the actions, feedback, and multimodal guidances. We build a server in Python that contains the state tracker and the guidance planner, and they communicate via network sort. So here's the demo.
If the user burned the salmon fillet,
You've burnt the salmon. Trash it.
the assistant asks the user to trash it, then redo previous steps done on the salmon to continue with the recipe.
Grab another salmon fillet.
Need a
Season
robot.
the salmon with salt for 5 grams.
I'm waiting.
Where is this house?
Fry the salmon for 100 seconds.
The assistant also utilizes explicit and implicit user feedback to understand users' preferences on guidance modalities. If the user turned the heads-up display on while seasoning previously,
Turn display on.
the assistant will turn it on again for a similar step.
Season the chicken breast with salt for 5 grams.
If the user gathered ingredients faster when highlighting an audio were on, the assistant will use these guidance modalities again.
Grab a can of turmeric powder.
In addition, the assistant estimates the duration for the user to perform different steps and optimize planning to minimize the completion time. If the user can only gather one item at a time and cuts the lemon slowly, it asks the user to gather a plate and a parsley leaf while frying,
Gather a parsley leaf.
because cutting the lemon at the same time will burn the cod.
Okay, the full video can be
Stop
seen
frying.
in the paper submission.
Transfer the
For evaluation, we tested the cooking simulator with 12 participant user study. There were two conditions. One condition is cooking a system with AMA, and there's a baseline condition that simply presents the first possible action from the state tracker. We asked participants to first learn the game environment in VR, and then we asked them to do a training task with AMA. This is to calibrate the user model. And we divided the user into two groups of 6 participants. One group start with the AMA, and the other group start with the baseline condition to counterbalance the learning effect. The results show that AMA significantly reduced the task completion time. People using AMA condition, they spend 280 seconds rather than 480 seconds on the baseline condition. We find AMA has minimal effect on task load, and we hypothesize AMA's performance advantage comes from the user model's ability to more accurately predict individual performance. To test this, we compare the user model's accuracy before and after the training task. And then we use the final cooking session as a test set. And we did observe a significant reduction in user model errors. So to sum up, using the MAUI architecture, AMA uses this modular abstraction, which is activity specification. For designers, they only have to provide domain-specific knowledge on the task they're working with. And then for users, we prove that this is efficient and adaptive. So finally, this is the summary part of the defense. AMA basically proposed a new holistic way of realizing multimodal interactions. We have frameworks that handles all the details in multimodal input and output, so that developers only have to provide domain-specific information in the format of our composable abstraction. And we are trying to provide an adaptive, intuitive, efficient, and capable multimodal app using experiences. And we come up with two definitions for composable abstractions. For explicit interaction, we have object-oriented state classes, and for implicit interactions, we have activity specifications. And we built 3 projects helping developers to build those multimodal applications. The benefits of MAUI are threefold. So first, MAUI helps reach feature parity in different modalities. On the left side, this is Uber Eats, which is actually probably one of the top food ordering apps in the US. It supports many features in the GUI, but the only 2 features supported with voice is how to reorder and how to track your orders. And then with React Genie, all of the demo apps we shown today have 40+ features in touch, and all of the features and combinations are available in voice. So apps we build with MAUI can easily reach feature parity across modalities. Another benefit is MAUI provides proper scaffolding to enable good experiences across the apps. Before, developer has to work with all of the low-level details and those actions by hand, and there's no standard structure for multimodal interactions. With MAUI, we provided modular abstractions, even IDEs, to help the developer build their apps so that they have good multimodal experiences out of the box. And finally, MAUI makes multimodal much more easier. Before, app developers would have to learn how to train, use, and integrate AI models into their apps, which is time-consuming and only available to the top developers. Now, with MAUI architecture, the framework can handle AI models so that developer can learn multimodal framework in an hour. Like all of those developer studies are like developers learn it very quickly. And studies have shown developer can build and improve multimodal apps in an hour, which is unimaginable before. My PhD work in multimodal interactions are not limited to multimodal frameworks. These are the frameworks I just presented today. I've also worked with a lot of interaction techniques on the multimodal side. We have Sounder, which can locate the user's location and direction they're talking towards just by listening to the audio signature. We have Do This Here, which is a precursor to React Genie and Genie Wizard. I've worked on Hybrid Track, which is about how do we use a hybrid setup of camera system to do full body gesture tracking. And I've worked on WhisperBuzz, which is how do we improve voice recognition on earbuds platform. So this is the final part of the talk. I'm going to talk about acknowledgement. Thanks a lot for all my committee members being here today. And thanks a lot for the valuable feedback on the way to the current stage of my dissertation. You are my role models. And thanks a lot for IXD lab members and OVO lab members for their support. I learned so much from all of you, and then also from HCI group and NLP group. And special recognition goes to Parker to help me make the MAUI diagram much better than the first generation. I also want to thank people who I'm working in this startup I co-founded called Skywalk. And then they are my friends, and then they are my co-founder, and they support me the whole way. One thing I cannot stress more is like all of those projects wouldn't be here without my interns. They really put their passion and thoughts into those projects. We worked hard and played hard together during many summer days. And I also want to thank my friends, my board game friends, friends I met at conferences, friends helped me film demos and participated in my studies. I know I made quite a lot of people sick doing the VR segway. Ride a segway while putting on VR headset, and it has huge latency. And I want to thank my advisors again. James and Monica are a truly amazing combination of advisors. James' experience in HCI and Monica's knowledge and passion in NLP and computer system helped me make all of the work become working and actually useful. I would like to thank my family, my parents, my grandparents, and Tianxi's parents. They have given me their utmost support along my longest education journey in my life. And finally, I would like to thank my partner Tianxi. She supported me both physically, emotionally, and mentally, and provided unlimited support when I needed them. And then, okay, so going back to the talk, today I talk about Multimodal AI-augmented User Interface Development Frameworks, or MAUI. And the key takeaway here is to achieve this multimodal feature, we want to be focused on right abstraction, a single programming interface for developers, and a unified user experiences for users. And thanks a lot for everyone to be here, and I'm happy to take any questions. For online, Monica, you can just ask questions, but if you want to ask questions, you can click the Q&A button. And yeah.
So yeah, why don't you take questions as they come up?
Sounds good.
Remember, silence is cool.
Thanks, Jackie. That was amazing. A super awesome talk. Like, actually, my mind is totally blown. For the MAUI framework, on I guess the first two, like React Genie kind of framework, is this something that works on like whatever platform? Like, is this something that could be implemented on like whatever, let's say like a mobile platform and a web-based and computer platform? Or how does that work?
Yeah, so React Genie currently is a framework on top of React. React is a web framework, and it has optionally support for a little bit of native iOS and Android app through React Native. So the version we have right now is web-based. So you can build a web app, you can build an app using Electron, I think, so that you can embed a web app into a desktop app. So those are all possible. We can easily expand it to React Native so that you can build a native-ish app on Android and iOS. So that's what we currently support. And then I personally believe like Apple and Google, they should just implement this, and then so that all of the apps in the future can be multimodal.
Thanks for a great talk, Jack. I really enjoyed hearing about how all the different components of MAUI work together and automate a lot of difficult tasks for developers. And I was wondering how developers handle the problem of error correction, error remediation using these more abstracted frameworks compared to traditional.
That's a great question. Let's think. So there are a few different kind of errors, right? So from here, so there are parser errors, for example, which is a very common kind of error. Right now, the actually is 90% is pretty high for the parser that I'm building with, but 90% is not 100% enough for our users. So one thing we noticed is that for the parser errors that we have, we didn't just went completely wrong. We will usually reach halfway there, or like at least we'll tell the user that this is not supported. So the user can fix actually a lot of them. And then one thing we plan to do is we can build something where we automatically collect the instances where the user says this is not enough, or the user issued a similar query right after their first query, which likely means the first query are not correct. And then we can gather those saying, oh, these are the commands that the user provided. And then we can maybe even do it in the same Genie wizard interface, so that developer can easily see what are the features users are asking for and what is the current status of support, which kind of like this.
Is someone monitoring the online questions?
I'm checking it. No question.
And really interesting talk. I guess I was curious about the user interface side of things.
Yeah.
Currently, like with Emma, I think like the user interface elements that are being generated are manually created, like pop-ups that appear on the screen. And I think that also allows you to think or adhere to general UI guidance. But going forward, maybe how would you envision maybe dynamically generated user elements to like bring that feedback and then create something that wasn't manually encoded?
Oh, for the AMA version.
Yeah.
I think AMA version is a little bit like I'm personally philosophically I want developer to be in control. So I'm not 100% on board yet with like AI generates all the interactions. So I would still want developers to provide some templates basically. So that's what I mean by like this multimodal UIs that I talk about when I talk about AMA. So I'm not talking about they're going to implement everything, but rather they're going to implement some templates. So they're not going to say, oh, which feedback we provide, but rather they're going to say, oh, maybe there are a few ways that we can provide feedback. We can show the instructions on big TV. We can show the instruction as a heads-up display. We can read the instructions to the user, and then maybe we can highlight the object user interaction. So those are kind of the feedback UI I imagine, and I currently think they should be generated. They should be at least initially built by a developer, but the framework will be able to compose some of them together to provide an experience tailored for the specific user. Yeah. And for the React Genie side, right now, so the developer can, similar to all voice frameworks, developer can do most of the customization. What the React Genie framework right now is just this button. So any app built with React Genie would have this button automatically populated. If you click on this button, you can do multiple interactions. Going forward, I definitely think this button should be able to be customized by developers. We can totally do that. And another thing I personally think should be the way to go is rather than having a button, we should have either a wake word or not even a wake word. Just imagine apps are a human being that you can talk with. So you just say what you want. The app uses the different components developer build to help you solve the problem.
In a lot of studies, you compare the React Unity specific tools with the simple VS code, but
Yes.
I was wondering if you could have you looked into comparing this to other augmenting tools like GitHub Copilot or something?
Actually, we have Copilot enabled for both scenarios. So when the VS Code scenario and the Genie Wizard scenario, we have Copilot enabled. Copilot is usually useful for implementation, and I haven't seen it to be very useful for feature discovery, which we are trying to do. But that's a good question.
Really great talk. For the, I guess the questions where I think it's 53% are still solved, for the other group of that isn't or doesn't have something comparable that the app is able to generate, are there certain groups of tasks that people tend to ask, or are there ways that I guess onboarding or like human in the loop sort of feedback can improve over time, how people know to ask those types of questions?
Right. So the way we run Elicitation studies, we just show a screenshot and tell the user you can say whatever you want to this app. So that's kind of maybe one part of the reason why there are so many answer commands, because if we say you can do whatever you want and then here's the app, they haven't used this app extensively, so they would say whatever they want. I can imagine that what if this multimodal interface is widely available and people have tried it a little bit, they will have better expectation of what is available and what is not available. But on the other hand, so that's why we are not trying to get to 100%. But we want to try to get, like this is right now, it's like 50-ish%. I think in my mind, I'm trying to get to like, let's say 80-ish. This is so that if the user first try this app, they found out half of their commands is not supported, they're going to be frustrated and never use multimodal again. So what I want to do is so that, like for example, if we get to 80 or 90%, the user would use multimodal and they would find multimodal to be working most of the time. And if that is achieved, the user would use more and more, and then they would get better and better, and they would know what is available and what is not available. So we're just trying to break that initial gap so that the user would like to try this multimodal interface at the beginning. That makes sense.
Other questions online yet? No. Okay, then we're going once, going twice. Any further questions? Okay, well then I think with that we can.
Well, for everyone for for being here. I can grab some cookie.